Assalamualaikum and a very good morning. My name is Wafa Natasha binti Wilson. So I am going to present my research project, which title is Effect of Catalytic Amount on the Reduction of Palm Olein with Fatty Acid. So we will look at 3 chapters that cover introduction in chapter 1, literature review in chapter 2, and the last one is methodology in chapter 3. Nowadays, researchers from all over the world have been studying new methods in chemical synthesis process to produce industrial and pharmacy products such as fuel, polymers, and detergents. So normally petrol-based products are widely produced, but this results in a decrease in petroleum supply, which causes the price not stable. So as a result, there is various environmental friendly sources for initiating green material technology in chemical synthesis have been discovered, and typically these sources have been traditionally used as ingredients or food usage for a long time, and the potential of this plant as an environmental friendly source in developing industrial products cannot be found. So in developing countries, vegetable oils are increasing to replace the animal fats due to the cost and health concern. Apart from that, there is currently growing interest in oil palm renewable energy such as biodiesel. This palm oil biodiesel is biodegradable, non-toxic, and emits substantially, which means less pollution, when burned compared to petroleum-based diesel. And for this product, palm oil will be discovered, which is derived from the mesocap of the oil palm fruit, and Malaysia economy relies on this palm oil production, as the country is the world's second largest producer of palm oil after Indonesia. Palm oil and extraction have high solid glyceride concentration, consistent without hydrogenation, and oxidation resistant, and it also has a long shelf life and high melting point, triglycerides, with a low solid content, and so it will be useful in product formulation. So for this paperwork, I'm going to do the research about converted palm oil into the fatty acid alcohol. So the synthesis method will be used in this research, which consists of 3 steps that include preparation of the starting materials, which is the reduction of palm oil and palm kernel oil, and sugar and glycosylation and deacetylation. But sugar, glycosylation, and deacetylation I didn't use for this project. So when we do the experiment through the reduction of palm oil to convert the palm oil into the fatty alcohol, it will give the inefficient for the conversion. So means that the conversion is below at 70% of efficient. So we decide, other than we use the palm oil as our main material chemical, there is the chemical that we provide, like catalyst, solvent, and some of chemical and materials, and using instrumental chemical analysis, which is GCMS and NMR spectroscopy. And also this study will discover the effectiveness of catalytic amount on the palm oil fatty acid. So for this work, PO fatty acid did not completely react, even though PO fatty acid are then converted into PO alcohol through the process of reduction. the conversion to that process is still inefficient. So by provide the catalyst of lithium aluminum hydride, the conversion to that process should not be less than 100% efficiency. And the galactoxide are synthesized from reduced palm kernel oil (PKO) fatty acid, and the PKO was selected as the alkyl chain since it is primarily made up of saturated fatty acid. And these galactosides are thought to be non-toxic since they are generated from food material, and to obtain the natural glycolipids in large quantities may be difficult since they are hard to extract in adequate quantities, and it will be challenging also in purification for biophysical research as well as synthesis of the lipids. So in order to overcome this problem, the researchers encouraged to develop synthetic glycolipids due to the current awareness that prefer environmental friendly technology to a higher level demand for biodegradable materials that can be synthesized from renewable resources and also low in cost. So the purpose for this research is to review the effectiveness of catalytic amount on the reduction of palm oil fatty acid and synthesize the reduction of reaction of palm oil with varying catalytic amount, as well as analyze the content of fatty acid alcohol of the PO palm oil using analytical instruments. And there are two instruments were applied for this experiment, which is nuclear resonance magnetic NMR spectroscopy that will perform using spectrometer, and is also use GCMS, which is gas chromatography mass spectrometry, where GCMS instrument is widely preferred in the real-time analysis of fatty acid. During the 14th to 17th centuries, some palm fruits were transported to the Americas and then to the Far East. It was written records of palm oil being used as a local food source by Europe travelers to West Africa in the middle of 15th century. In the late 18th century, archaeologists discovered a substance that they concluded was originally palm oil in a tomb at Abydos, Egypt, in a range of 3000 BCE, which meant the mass of several kg of palm oil were found in a vessel enclosed in a tomb at Abydos. In the early 19th century, European plantations were set up in Central Africa and Southeast Asia. German investment in Cameroon brought about the discovery of the Tenera breed of palm oil in the year of 1902. This high-yielding breed is what is used today in large-scale plantations. The palm oil was introduced into Malaysia by a Scotsman named William Syme and an Englishman by the name of Henry Darby in the year of 1910. So that's why Malaysia has a company of palm oil plantation which known as Syme Darby Plantations. Technological improvements in edible oil refining and transport drive the usage of unhydrogenated palm oil in Western foods in the year of 1940 to 1960. Malaysia emerged as the world's largest palm oil producer after Indonesia by 1990 in a global palm oil production that was reached close to 11 million metric tons. During the 14th to 17th centuries, some palm fruits were transported to the Americas and then to the Far East. It was written records of palm oil being used as a local food source by Europe travelers to West Africa in the middle of 15th century. In the late 18th century, archaeologists discovered a substance that. What is palm oil? Is palm oil similar to palm kernel oil? Palm oil is not similar to palm kernel oil. PO palm oil and PKO palm kernel oil have a different physical and chemical properties, which they are only depending on their intended application. And the palm fruit looks like a plum, and from the fruit there are two distinct types of oil are produced, which are palm oil and palm kernel oil. PO is extracted from the flesh or mesocarp of the oil palm fruit, while PKO is extracted from the kernel or seed of the palm fruit. Both of this oil comes from the same fruit, but they have very different unique, which means that PO is a balanced composition of saturated and unsaturated of fatty acid, coupled with nature's gift of high vitamin E content. The oil is naturally very stable, and PO is mainly used for edible purpose like biofuel, while the PKO is mainly for non-edible purpose like cosmetics, soap, and detergents. So when you refer to the table 1, PKO is contain 85% of SFA, while PO is only contain 50% of SFA. And from the table 1, the major fatty acid in PKO are about 47.8% of lauric acid and 16.3% of myristic acid and 15.4% of oleic acid. So this means that there is no other fatty acid is present in amounts more than 10% of the oil, and this will be advantage for lauric acid, which gives PKO and indeed coconut oil in their sharp melting properties, which are defined as hardness at room temperature mixed with a low melting point. Even after full hydrogenation, the melting point of PKO does not rise much above aura temperature. So PKO is roughly 82% of saturated, which is significantly higher than other non-liquid oils such as soybean oil, which is only 16% saturated, and sunflower oil, which is only 12% saturated. So the next slide is about the processing of Malaysian palm oil at the mill. So in the plantations, the trees are watered and treated with fertilizer as needed while they grow. So after 30 months, they are considered mature and are ready for their first harvest, and the process will be repeated every 7 to 10 days. The seed before that are planted in a nursery where they can receive daily watering and upkeep for the first 8 months of their life before being transplanted to the plantations. So the palm oil fruit will grow in bunch known as FFB, fresh fruit bunch, and in order to harvest the FFB, the harvester uses a long sickle to remove it from the palm tree. FFB, which are ready to be harvested, can be easily identified due to the bright red-orange color of their palm fruit. The harvested FFB are transported in trucks from the plantations to the mills, where they are sterilized using steam. This prepares the FFB for stripping, which will remove the palm fruit from the bunch and also deactivates any enzymes which may cause the FFB to getting worse in quality. Once the FFB has been stripped, any waste will be reused, so the long fiber in the stalks can be used to make mattress and car seat cushions, while the remaining empty fruit bunch are returned to the soil where they help retain moisture before serving as fertilizer when they eventually decompose. So after being stripped from the FFB, the palm fruit is processed into two main products, which include crude palm oil (CPO) that is extracted from the flesh or mesocarp of the oil palm fruit, and palm kernel oil (PKO), which comes from the kernel or the hard seed in the center. The first step is to press the fruit, which squeezes CPO crude palm oil from its mesocarp. The oil is then screened and clarified to ensure it is free from contamination and dried to meet standard CPO specifications. Next, the CPO is transferred to a refinery where it is processed into edible oils such as cooking oil, cream, and margarine, and also in oleochemical that used in detergents, biodiesel that used in fuel, and last one is lauric acid that used in cosmetics and soaps. So in the depericarpus station, a cake, which is a mix of mesocarp fiber and seed, will be separated. So the mesocarp fiber will be used as biofuel in the palm oil mill's boiler, which can produce steam to drive turbines to the power of the mill, while the remaining palm seed, or known as kernel, will be cracked and deshelled. The shells are taken away to be sold as biofuel, while the kernels undergo further crushing to produce crude palm oil and palm kernel expeller (PKO and PKE) in respectively. So the crude PKO also undergoes a refining process before it is used in the making of food products such as ice cream, non-dairy creams, while the leftover PKE is generally used to make animal feed. So in the website of Asian Agri, the leftover of wastewater from the palm oil production process, which called palm oil mill effluent (POME), is also recycled either as fertilizer or as fuel for biodigester, which will be converted into biogas. So that will be result in the natural gas to power the mill and operation, as well as provide electricity to communities. For synthesis of reduction of fatty acids to alcohol mechanisms, long-chain aldehydes and alcohols have been found in bacteria, insects, plants, and animal tissues as lipid components. Fatty alcohols play an essential role in a variety of organism metabolic pathways, since they can create fatty acids while also forming reduced forms of enzyme cofactors in a reaction involving large positive free energy changes. Although various alternative enzymatic processes that produce fatty aldehydes and alcohols have been identified, the reduction of fatty acid is the major pathway for the synthesis of fatty alcohols. So in most cases, the reduction of fatty acids requires ATP, CoA, and either NADH or NADPH. Alcohol is usually the primary product of fatty acid reduction in crude or partially purified enzyme preparations. Furthermore, only the fatty aldehyde was produced as a reaction product for some of the soluble fatty acid reductases that have been partially purified from different sources. So when according to research, the requirement for COA for fatty acid reduction suggests that the reaction takes place through the formation of acyl CoA. These fatty acid reductases have been shown to be a multi-enzyme complex with two distinct activities, which include all protein synthesis and all CoA reductase. So for the diagram 1, synthesis of saturated straight chain fatty acid through the fatty acid synthase 2 in E. coli. This diagram indicates how fatty acids are synthesized from CoA and NADPH through the action enzymes called fatty acid synthesis. The enzyme of acetyl-CoA is activated for the malonyl ACP in step A. So in the next stage, malonyl-CoA is activated to react with acetyl-ACP in B. While in step C, an ACP-bound acyl chain reacts with chain malonyl ACP to lengthen the chain. The carbon tricaton is reduced to a hydroxyl group in step D. Then the water is removed in the next phase in step E. Then we'll reduce the C2C3 double bond as a last step in the step F. Note that during fatty synthesis, NADPH is the reducing agent, whereas NAD is the oxidizing agent in beta oxidation, which is known as the breakdown of fatty acid to acetyl-CoA. And in biosynthetic reaction, NADPH is consumed, while NADH is produced in energy-yielding reaction. So, synthetic glycosides are prepared through enzymatic synthesis and chemical process, or a combination of the two methods. So, in this regard, the galactosides was synthesized through the modified version of this method using glycosylation procedure by researcher Hashim et al. With minimal modification, which is described in detail at the methodology section. Lithium aluminum hydride, a reactive agent that can effectively reduce carboxylic acid and esters to the appropriate alcohol, that used to reduce palm kernel oil PKO to alcohol mixture. The attractive characteristic for this catalyst, when combined, it will place it in a unique position, which include easy preparation, stability at room temperature, soluble, and has a good ratio of reducing capacity to mass, excepting the hydrogen when compared to other reducing agents. And also the reduction takes place at room temperature, and there is no unusual chemical equipment is required. Furthermore, throughout the reduction, double bonds are unaffected. This is advantageous since both palm oil and palm kernel oil contain considerable amount of double bonds. Next, in the slide of catalytic effect on palm oil reduction, the utilization of heterogeneous catalyst system, which include cationic exchange resins, is a very interesting alternative for carrying out FFA esterification. Metal oxide heteropolyacids supported on silica and carbon, aluminophosphates, and silico-aluminophosphates, molecular sieves and clays are examples of these resins. While the clays have presented a substantial interest in several organic syntheses as catalysts. In particular, the clays activated with acid treatment as a high concentration of Lewis and Bronsted acid sites, which allows oil esterification with high FFA concentration. As you can see this slide, that is the reversible chemical equation for esterification reaction of FFA. So the esterification reaction will be carried out in such a batch type tube reactor, which composed of glass with 200 ml, and 31.1 mm of external diameter. For each experiment, a molar ratio of 12:1, which is methanol to oil, and a palm oil quantity of 20 grams were utilized in the esterification reaction. The specific amount of catalyst is required for slow esterification reaction. The reaction will occur by taking different catalyst weight percentage, which is 0.5, 0.8, 1.0, 1.5, 2.0, and 2.5 weight percent of catalyst. So according to previous research, by increasing the weight percentage of catalyst from 0.5 to 1.5 weight percent, the percentage of fatty acid conversion to methyl ester will be increased, while the acid value of oil will be decreasing to less than 1%. This means that there were no visible changes in conversion or acid value when the catalyst was increased to 2 to 2.5%. The appropriate catalyst concentration is 1.5 weight percent. Esterification is normally carried out in the homogeneous phase in the presence of acid catalysts such as sulfuric acid, hydrochloric acid, and p-toluene sulfonic acid. Many researchers have found that by using acid catalyst in homogeneous phase will cause many inconveniences, such as difficulties in recycling, high temperature, corrosion, and environmental problems, but not acidic heterogeneous catalysts, which do not have these problems such as solid catalysts. In fact, trans-esterification using heterogeneous catalysts that requires 200 degrees Celsius to achieve more than 90% of conversion within the time scale of the experiment. On the other hand, esterification of fatty acid was efficiently carried out in a semi-continuous reactor, which allows operating in the presence of a very low alcohol concentration in order to prevent the degradation of catalysts. So the next slide is research methodology. This chapter will focus on the experimental methodologies that used to achieve the objective of this research. So in sum, the analysis will be done by using two types of analysis, which include synthesis method and instrumental chemical analysis. The materials and chemicals that used in this experiment include palm oil, water, the catalyst of lithium aluminum hydride, which is a gray solid and effective reducing agent that can be used in chemical synthesis in order to reduce the alcohols such as esters, carboxylic acid, and coal aqueous sulfuric acid, chloroform D solvent, which is a standard purity solvent for NMR, nuclear magnetic resonance analysis. It is widely used in high resolution NMR studies due to its high chemical and isotopic purity. And the last one is diethyl ether. Diethyl ether is commonly used as a solvent in lab because due to its high volatile, colorless, sweet-smelling, and extremely flammable liquid. So for the sample collection, we are taking the Malaysian high-free fatty acid of crude palm oil that was obtained from the refinery Malaysia. In the synthesis method, it is use a procedure that called reduction reaction of palm oil with varying catalytic amount by presence of catalyst lithium aluminum hydride. So by using a standard reduction procedure, PO palm oil and PKO palm kernel oil were converted to alcohol. In a 2-neck round bottom flask, a suspension of 33 mol lithium aluminum hydride in 40 ml diethyl ether was stirred under closed condition. In order to avoid the strong reflux, 22 mol of PO or PKO was added in 30 ml of diethyl ether and slowly added to the suspension through the dropping funnel. And after the last addition of the oil, ethyl acetate was added, followed by water, drop by drop, in order to deactivate excess lithium aluminum hydride. An ice water bath was used to cool down the heat generated by the process. So the organic solvent was then evaporated after the PO or PKO alcohol mixture washed with 100 ml of 10% of coal aqueous sulfuric acid. So the next subtopic that covers in the last chapter is instrumental chemical analysis, which divided into two instruments. The first one is gas chromatography, mass spectrometry, GCMS. As you can see, the size of the spectrometry column was used to measure the PKO sample, which was programmed from 75 degrees Celsius to 300 degrees Celsius at 10 degrees Celsius per minute, and then maintain for 5 minutes at the final temperature. The injector and detector were both set to a temperature of 200 degrees Celsius and 360 degrees Celsius respectively. Helium was used as a carrier gas. So according to the previous literature, immobilized C. Antarctica B enzyme was used to minimize the damage of the particle enzyme. Titration techniques were used to analyze the crude and treated oil for FFA, while for using gas chromatography GC will be used to analyze mono, B, and triglycerides. So the next slide is the nuclear resonance magnetic NMR spectroscopy. So for this instrumental chemical analysis, recent research utilized the spectrometry HNMR in order to identify and characterize the glycosides based on the PO and PKO. So at 500 mH Z, NMR spectra were obtained by using a variance NMR system spectrometer. So in the sample preparation, the solvent methanol D4 was used. Other than that, chloroform D also that used in this experiment. The maltosides were then analyzed at the room temperature. However, the lactosides required a higher temperature of 55 degrees Celsius due to an insolubility problem at lower temperature. So according to the previous researchers, a spectrometer FT NMR 600 mHz cryoprobe advanced 111 600 mHz model was used to perform the NMR spectroscopy analysis, as well as only from me. If you have anything or want to ask, you can comment at the below and subscribe, and don't forget to subscribe and like. Thank you.